GM everyone, this is Raphael, DevRel at Atrium. Thanks for coming back for another public event. This week we have Olympic. We have Sarah and Ashnu from Olympic. Olympic is an IDE, AI static analyzer extension made to help devs find vulnerabilities in their smart contracts before their audits. Um, they're also one of our founder perks. Our perks allow our HM alum to get Web3 services at a discount. So please, Sarah, take it away.
Hi, everyone. I'm excited, to be here and share a little bit more about Olympix. I'm Sarah Hicks. I'm VP Strategy here at Olympix. I'll hand it over to Anish for a quick intro, and then we'll dive into the workshop.
Hey guys, I'm Manish. Nice to meet you all. I'm head of product here at Olympix, work across all of our tools, and then would give you guys a small quick demo at the end of this presentation.
Nice. Thanks, Anish. So the idea behind Olympix is that audits alone are not foolproof. When we look at exploits that have taken place in the space, obviously as DeFi has kind of emerged and grown, the amount of smart contract exploits has also grown and evolved over time. And so when we look at 2021, we were looking at 3.5-ish billion in exploits. When we're looking at 2022, that grew a little bit. We saw a little bit of a dip in 2023, but we see that as kind of a bear market anomaly. And then things picked back up again in 2024, and we're projected to be at kind of an all-time high in smart contract exploits in 2025 based on projections from the first 6 months of the year. By June 2025, we were already looking at 2.17 billion stolen. Basically, when we're looking at, we kind of keep pace with all the exploits that take place in the EVM space, and we see that there's approximately 5 major exploits every 2 weeks. So something that one really needs to keep an eye on. And 90% of those exploits took place on audited code bases. So for a long time, the sole security assurance, if not the primary security assurance for many teams for smart contracts, was the external third-party audit. But we can see time and time again that an external third-party audit alone is not foolproof. An audit is absolutely necessary. It's critical, but it is only one layer in a kind of layered, robust security approach. So the problem with audits is that first of all, they're inherently reactive. You've already finished writing the code by the time you get to an audit. They're also limited in scope. They're limited in time. They're limited in that human beings' capabilities. They're limited by that human beings' knowledge of your code base. We see that auditors spend a huge chunk of the audit time, getting to know your code base, and then they go and find the vulnerability. So there's a whole bunch of inherent limitations to audits, and that's what contributes to the fact that hacks are taking place on audited code bases, regardless of whether you're working with the top auditors at the top audit firms. So you can see here on this slide, these are some examples, real world examples of hacks that have taken place in the last year or so on audited code bases. So major hacks, major DeFi exploits taking place on code bases that have been audited once, twice, 3 times, sometimes 10 times. So in the case of the Euler exploit, which you guys have probably heard of, 10 audits by 6 firms, still led to $197 million exploit. So long story short, audits alone are not foolproof. That said, don't fret, there are solutions to this. So when we do postmortems on the exploits that have taken place, we run our tools on the pre-audit commit that was also given to these auditors, and we verify whether or not we would have found the vulnerabilities that led to those exploits. And thankfully, the majority of the time, the answer is yes. So this number is actually growing as we evolve the tool suite and as we improve the tool suite. But today it sits around 60% of these major hacks in the EVM space were preventable with Olympix. And we have a suite of tools that prevent different types of smart contract exploits. And again, so all of those examples that we had listed on the other slide, we would have been able to prevent those with the Olympix toolkit. And this is what we want to talk about with you guys today, is how you can leverage these forms of automated testing so that you can find these vulnerabilities ahead of time before you go to external audit, so that you're adding in an additional layer of security assurance that is much more scalable, much more cost effective, and kind of lower lift than external third-party audits. There's a couple of trends that have emerged in the research that we've done. So one of our tools is our static analyzer. We'll walk through that in a little bit of detail in just a second, but our static analyzer sort of acts like Grammarly for code. So it's sitting alongside developers as they write their smart contracts, and it's flagging vulnerabilities that are being introduced into the code by recognizing patterns and saying like, hey, this is a pattern that's been exploited in the past. You should look at this and make sure it's not exploitable in your code base. And so within the tool, we're seeing which of these vulnerabilities are being introduced. Of course, with Olympix, they're also being addressed and they're being fixed. But by looking at what's being introduced into the code with Olympix, we can kind of extrapolate and infer what is being introduced and potentially not fixed across the industry. And then we kind of correlate this with the hacks that we're actually seeing take place in the EVM space. And those two metrics together have painted a picture of what the most common smart contract vulnerabilities are that are still being introduced to smart contracts and being exploited in smart contracts. And it's funny because these are the same ones that you're seeing time and time again. Like these are the same attack vectors that you were seeing in 2023. And when I have conversations with people, like I'm at Token in Singapore right now, I'll have conversations with people at side events and I'll say like, our static analyzer, it flags some low-hanging fruit like reentrancies, cross-contract reentrancies, things that people think are kind of obvious, but they're still missing. And people will say to me like, no, surely people are not still getting hacked with reentrancy vulnerabilities. No, they are. It is 100% still the most common attack vector that's being hacked. And it's the most common attack vector that's being introduced into code bases. So when we look at these trends, this is just to kind of flag to you guys, there are low-hanging fruit that you might be missing that simple tooling can help you pick up on. And also these are things you should keep an eye out on. So the highest kind of percentage point of a certain type of vulnerability that's being introduced that we see time and time again is reentrancy, and that's across classic reentrancy and cross-contract reentrancy. The next top vulnerability or attack vector that we see introduced into smart contracts is constructor validation, and then the third is unsafe downcast. We have built, thankfully, detectors that look for exactly these issues within Olympix, as well as all of the kind of less common attack vectors. And we'll dive into how our various tools in the Olympix proactive smart contract security toolkit flag these common attack vectors and how you can prevent them. So let's dive into Olympix. So Olympix is a suite of tools that enables engineers to find and resolve vulnerabilities in their smart contracts while they're writing code with tools rather than relying solely on that external third-party audit. So it allows you to surface vulnerabilities earlier in development, which means that you're reducing audit reliance as that sole source of security. You now own a huge chunk of the security assurance. You're fixing those problems ahead of audit, which means that when you go into an audit, you're freeing up a bunch of that external auditor's time to focus on sophisticated novel vulnerabilities rather than a bunch of this low-hanging fruit that you could have resolved yourself with tooling. That means quicker remediation cycles on your external audit. That means a cleaner audit report. You're going to come back with fewer audit findings on your external audit, which signals stronger security to your stakeholders. We see often, especially with early stage projects, you might go into an audit underprepared. That external audit comes back with a ton of findings. You then can't publish that first external audit report because there are too many vulnerabilities. You don't want to be publishing a report that has like a whole bunch of criticals, a whole bunch of mediums. So you end up getting the report, making the fixes, and having to go again for another external audit, which is massive cost, right? These audits are a massive one-off fixed cost that's limited to that scope of that audit. If you're leveraging Olympix and you're clearing away a whole chunk of the vulnerabilities before you go to the external audit, you don't have to worry about that. You've done that first audit in-house. You're going to that external audit. You see fewer findings on that external audit. You can publish that first one right away. And the other piece that's very critical is just that, again, audits are not foolproof. So Olympix can also help to catch things that an audit might miss. A ton of our clients have come to us through this path of they were audited multiple times. They still got exploited. We ran our tools, like I mentioned earlier, we run our tools, we do a postmortem on that same commit that they gave to the auditor, and we prove that we would have flagged the finding or the vulnerability that led to the exploit in spite of the fact that they were audited. Then those clients come aboard with us and they leverage us before they go to external audit. So those are the kind of overall benefits with Olympix. And obviously, ultimately, the goal for you guys as builders is just to be able to deploy safe code faster and in a more kind of cost-effective and scalable way. So when we look at how Olympix helps enable these benefits, we've got two kind of categories of tooling. So we've got our continuous development stack. You see that on the left-hand side there with the green. So there's 3 tools that you're leveraging in continuous development. Those are the ones that we're going to have a look at today. We're going to do another session in a couple weeks' time where we focus on the right-hand side there, the audit prep. So just focusing on the left-hand side, we've got this continuous development stack that starts with static analysis, moves on to unit test generation, so helping you make sure that you hit your kind of branch coverage, and then mutation testing, which enables you to add another metric for measuring the robustness of your test suite. And yeah, as I mentioned, we're going to focus on part 1, which is that continuous security toolkit today. First things first, we're going to dive into static analysis, and I'm going to hand it over to Anish to kind of walk us through, first of all, just conceptually like what static analysis is and why it's even important to leverage at all in your development. And then we'll talk about how Olympix can help to automate it. So I'll hand it over. And of course, we have time at the end for Q&A. So if you have any questions about any of these tools, note them down, jot them down. You can also like maybe pop them in the chat, and Raphael can help kind of keep track of them, and then we'll tackle them in the Q&A at the end. But I'll hand it over to Anish.
All right. Thank you, Sarah. Let's get started. So static analysis, the name static is implying that we are statically trying to detect bugs in your code base without actually executing them. So that's the main idea behind static analysis, and why it's useful. It's useful because it's very fast. So you can essentially run static analysis over and over again on every code change, and it's very cheap and very fast to run. So that's what we are doing. So we are taking a static picture of your code base and then trying to find bugs in them. Now, how do we do that? We have over time built a database of what bad patterns in your code base could be. So, for example, if let's say the Li-Fi hack that happened last year happened because of this one vulnerability, and we can extract a heuristic, which will say, for example, you should never forget to initialize variables that are being passed to your constructors. We'll keep that heuristic and make a detector out of that, and then that could be reused further in the future to make sure that you're never ignoring to initialize this variable, right? Or you never forgot to initialize this variable, and that's what static analysis can do. It can help you identify all these bad patterns that are very easy for these machines to detect, but very easy for us humans to forget. So for example, Sarah mentioned reentrancy, right? Reentrancy can be very easily modeled as a checks affects interaction violation. Uh, and a lot of humans know that as well, but it's still very hard to actually follow that through. Well, when you're just looking at your code manually, right? Because these smart contracts have such complicated interaction patterns, such complicated code paths. It's very easy to mess the ordering up. It's very easy to mess the function calls up in terms of order, and like not even realize that there's a reentrancy, and that's how these hacks still continue to happen, right? And so that's the idea of static analysis. The idea is that it's not supposed to be a standalone tool. It will be one part of the process. Ideally, the first part of the process will sit with you while you're developing, right? And let me show you how it looks like when you write with Olympix. Perfect. Hopefully you guys see my screen. What I have here is I've cloned the eigenlayer repository. This was one of their dev branches. So this was still a work in progress commit, and that's the point that you'll be running the static analysis. Okay, so this is what the UI looks like. The dots here represent severity, how well they represent our confidence in whether it's a real vulnerability or not. If you click on any particular finding and then hover over it, there's more information about why we are flagging it. So for example, there's this external call. If you follow this call chain, and that call is breaking the checks fixed interaction pattern, right? So there might be a potential reentrancy in there. Now, if you don't know about the vulnerability being flagged here, you can just click here, and there's much more information about what the vulnerability itself is. There's information about what reentrancy means. There's links to hacks that have happened because of it, documentation surrounding it, etc. And finally, we give you an example on how this was exploited earlier, how this has been exploited in the past, sorry. And then finally, we tell you what you can do to fix it. Some of these findings also have a quick fix button. So if you just right click on it, and it will automatically fix it for you. All right, that's the UI of the static analyzers. I'm sure some of you guys would be familiar with static analysis. And I would like to just also show you how we differentiate from other tools. So the first thing was speed. So you saw that it ran very fast. And if I comment something out, and if you look at the number over here, you'll see that this number also updates really fast. The idea is that this is supposed to be a real-time tool that will sit with you while you're developing and then update really fast and give you that real-time experience so that you can fix these bugs as they appear. We also have a GitHub integration, which allows you to have the same results but in your CI. So you can choose to block on these results. So if I click on any particular finding, it's again the same information. There's the same tooltip that you saw earlier, and then there's a link to the same article that you saw on the side of the extension. Um, GitHub also provides you a timeline, so it shows you exactly what commit, what date this thing appeared at, and if it's fixed later, it will also show you where it got and how, what commit it got fixed at. So you can keep track of your issues essentially there. All right, that's static analysis.
Awesome. So yeah, that's the first tool in the kind of Olympix developer toolkit. The idea is that you're using that as any shared, you can use it from day one development, kind of sitting alongside you in the VS Code extension, or you can be using it all the way up to kind of your final checks that you're doing before an external audit through GitHub and kind of everywhere in between. You can also trigger it through the CLI if that's something that you want to use. And then the next tool in our stack is our automated unit test generator.
We'll start off with the static analyzer, and we'll start with
this is here in case our demo didn't work live, but it did, thankfully. So unit test generation, here you go.
Sure. All right. So the main idea behind this tool was that coverage is necessary. We don't think coverage is everything, but we think that branch coverage is just bare minimum. We say that it's table stakes for any secure piece of code. I think security starts at having good coverage. It makes sure that you have even thought about all these various branches that you that might exist in your code base, and that's what we try and deliver here with the unit test generator. What this tool does is it will go in, it will generate tests for you for the branches that you have not already covered. This could mean that you would start with no branches covered, just give it access to your subject contract, and it will generate tests up to like a base percentage for you. So it could go from 0 to 40% if you'd like to. The other way around is that you give it the base of, let's say, the complicated base of 80%, and it will find all the edge cases and all the edge branches that exist in that contract, and will try and generate test cases for those for those other branches. What this allows you to do is think about what different behaviors might exist, and then have concrete POCs as unit test cases, which are testing these branches, right? And then this will just help you understand your code behavior much more. Let me show you what we generate. Okay, so I had this Merkle tree contract lying around. It, as you can see, had 0% branch coverage. Went and ran the tool. It ran for 3 minutes and then could generate 95% 100% branch coverage, 95% line coverage. Let me show you what we generated. Okay, so this first test was given by me to the test generator as a sample of what I want my test to look like. So I was essentially asserting for a good test name, a bunch of comments, and then finally a good assert statement at the end, explaining what I'm asserting for. And then everything below this line is generated by our test generators. Uh, and let me show you some example tests to demonstrate what it generates. All right, let's look at this one, for example. So it's trying to test the lock2 seal true branch. It created a Merkle tree contract, and then it did all of this to test it. As you'll see here, it's adding a lot of comments explaining exactly what it's doing. In fact, in pseudocode, it's explaining why it's asserting for what it's asserting for. It has good assert statements for each assertion, and there are multiple assert statements every step along the way. Um, which I would say is a decently high quality test. So this is what we usually do. We'll generate tests for all the branches you have not already covered with very high quality test.
And can you share just briefly the kind of difference between this and if developers are trying to use something like Claude or ChatGPT or some other kind of widely available model?
Of course, yes. there are a couple of differences. The main difference is that our models have been trained specifically for unit testing. So what we have done is we have looked around the entire ecosystem. The good thing about the Web3 ecosystem is all of it is open source. So all the good quality high stakes unit test suites are public, and these models have been trained to generate test cases based on these very high quality repositories. So we understand writing good tests much better than these other tools. The other difference is that this is not just chat, but this is an entire system which helps you generate unit tests. What that means for you is that there's only a one-click trigger process that you need to do. You'll just let our test generator know that you want to generate test coverage for this branch, and then we'll take care of all the rest. Uh, you'll just receive an email with definitely compiling and passing tests after some time. All the prompting, reprompting, etc. is being handled completely on our end. Whereas if you are familiar with trying to have any of these tools like ChatGPT or Claude generate code or unit test for you, you'll see that they often generate tests which are like 99% okay, and then you need to debug it for a bit, and then that debugging cycle leads to more debugging, and that process itself takes a couple of hours. We are trying to eliminate that process. This is a one-click process that you'll definitely get compiling results.
Thank you, Anish. So that moves to the next and final tool, which is in that kind of continuous development stack, and this is mutation testing. I'll hand it over to Anish to dive into what mutation testing is as kind of a foundation, and then how you can kind of implement it with Olympix.
Sure. So mutation testing is a newer testing methodology being adopted in Web3. It is pretty common in Web2 and very high stakes operations. So for example, if you look at GCC, right, like the C compiler, you'll see that there's mutation testing on the compiler. Or if you look at aerospace softwares where criticality, where accuracy is very critical, you'll see that there's mutation testing being employed there. So stuff where accuracy is of the utmost importance, mutation testing is a commonplace, and in Web3 it unfortunately is not, and we are trying to make it commonplace. Now, what is mutation testing? The main idea is that we introduce small changes in your code base. These changes are called mutants, and then for each change that we introduce, we'll run your test suite before and after introducing that mutant. The idea is that your test suite should start failing after we introduce that mutant. Let me give you an example to explain how this works. Suppose you have a super important function somewhere in your code base, which is protected by the only owner modifier, right? So only the owner can call this function. I'll go and I'll remove the only owner modifier, and then I'll run your test suite. The idea is that your test suite should start at this point failing, and it should detect that there's no access control on this super important function. And if it's not, that's an incomplete test suite. So you can think about it as a much more relevant coverage metric for your test suite to make sure that your test suite is actually testing all the branches that exist in the code base. All right, and let me show you what we generate. Just pulling it up. Okay, there we go. So again, these results are accessible in a CI. So if you run it in with our GitHub integration, you'll see a report like this. You'll get an overall mutation score, which will tell you how many mutants were generated, how many mutants were killed, and that's what the score is. How many were killed over how many were generated, and how many of them survived. A mutant is said to be killed if it was detected by your test suite. So ideally, you want all your mutants to be killed and none of them to survive through your test suite. So you want this score to go up, and up is better. We provide code scanning results again. So just like you saw for static analysis, you'll have similar kind of findings. It will show you what the before code was and what the after code was. So for example, here on this line, there was this or operator, and we changed it to an and operator, and this survived through the test suite, which is bad. So this means that there's another unit test that's required to kill this mutant. Let me show you some example mutants that we generate. Sorry. This is, by the way, the other way to get the mutation report. So you can, if you don't want to have it on your CI, you can run it by our CLI, and then you'll get an email with the report, and it's the same results. So in this more detailed report, each row is one mutant. So for example, in line 235 in bridge.sol, there was this line of code, which was an emit statement. So it was emitting an event in this function. We removed that emit statement, and that was not detected by the test suite. This is very important. For example, if that emit event is being captured in the front end and like front end depends on it, then like you definitely want a unit test that's definitely expecting that emit, right? And that's what mutation testing is.
And the idea with mutation testing is that it's kind of mimicking bad commits that are either accidental or malicious. But again, like with static analysis, how the detectors are kind of heuristically determined based on real world hacks. Same thing with mutation testing. So the particular mutants that are introduced are determined by our mutant operators, and those mutant operators are, again, kind of powered by these heuristics based on real world bad commits that have led to hacks. And to give you some examples before we kind of go into Q&A, and I saw that there was at least one question that came or comment that came into the chat. There are some real world examples of hacks that have been prevented with these tools. So walking back to static analysis, which happens as a first step, there's a ton of exploits in the EVM space that would have been prevented just by this tool alone, even though it is surfacing these kind of low-hanging fruit. So some examples include like the $12 million Ronin exploit, the $11.6 million LeFi exploit, actually even the Euler exploit, that $197 million exploit that would have been prevented with the static analyzer. Unit testing, this is more of a security compliance tool than it is like a pure bug finding tool, right? This is helping you to achieve that branch coverage metric. It's not really specifically looking for bugs. That said, if it does detect things in the code that aren't working properly, it'll flag those to you as a failing test, and then you can go back and look, and you can make sure that it's the code is behaving properly versus there's something wrong with the tests. And then mutation testing again is looking for vulnerabilities. So a good example of a vulnerability that would have been flagged by mutation testing is the PenPy exploit. So $27 million exploit. It was a missing reentrancy guard that mutation testing would have pointed out. So that's that kind of proactive developer toolkit that exists, integrated kind of directly into your development workflows that you can use to surface more vulnerabilities as you're kind of continuously building and writing your smart contracts. Let's address any questions that have popped up. I saw there was one. Oh, let me go back here. There's one in the chat. Another one just happened on a protocol deployed on Hyperliquid. Yes. Do you, whoever kind of popped that in, Manuel, do you know the kind of details on that, or did you see what the root cause was? Sometimes it's like there's a delay before people will kind of release what the root cause was, but did you see what that was? Feel free to
No, no,
chat
no.
more in.
The details weren't really displayed
Okay.
yet, so we're waiting to see the details later on. But it was just information that something has happened on the protocol.
Gotcha. So as soon as that comes out, like as soon as it's available, the information on what happened, we'll run our tools and see whether we could have prevented it. Like if it is a smart contract exploit, if the audit that took place on that code base is public, then we'll go back and run our tools and see. But yeah, absolutely. Could well have been a smart contract exploit. I saw a question as well. Does Olympix support analysis for Rust-based languages? No. So today it is just EVM. It's just Solidity smart contracts. That said, it is something that we're looking to kind of expand over the next year or so. So definitely kind of stay tuned. But today, just Solidity smart contracts. And then Manuel, you also made a comment with a cross-contract call, CEI can easily be validated, 100%. And no other static analyzers, as we mentioned a bit earlier, no other tools, no other static analyzers would be able to detect these violations of CEI across multiple function calls. So you want to leverage a tool that's kind of as robust as Olympix, as opposed to these open source tools like Slither, maybe that you might have come across, because they just won't be able to detect that sort of sophistication of vulnerabilities. Any other questions on
Robust
the
is a good word. I like, did my pre-readings before and I didn't know how robust Olympic was. Mutation testing is definitely super interesting because never ever heard about that. We heard about fuzz and we hear about formal verification, but this is even like a step above that where we're just going to change a few things and like those problems, like changing the and the or, happens all the time and then
Right.
breaks everything. So and those are the ones that skip through all the tests.
Yeah.
Interesting.
Exactly. That's so true. And it's very, very labor intensive to do that manually. Mutation testing is an absolute pain in the ass if you wanted to do it by yourself. So definitely something worth exploring. Manuel, question?
Yeah, I just wanted to find out how fast do you upgrade your service to accommodate some of the new features that have been implemented in new upgrades? Like now Ethereum is making upgrades on the protocol. How fast do you enable upgrades so that if someone is trying to build using the new protocol of Ethereum, they're still as secure based on the new features that have been introduced, maybe accommodate some of the opcodes that might be exploited if someone built a tool using the new protocol.
Good question, Manuel. And that's the core of our team. We really turn around these things very fast. Like we keep a constant eye out on all language updates that are happening, all ETH updates that are happening, all hacks that take place to constantly keep upgrading our detectors. So on average, we'll change approximately 4 to 6 detectors per quarter, or add 4 to 6 detectors every quarter. So we this turnaround and constant refreshing is again the core of Olympix.
And we contribute actively to the Enterprise Ethereum Alliance security specs. So we're, yeah, kind of like finger on the pulse of everything that's going on in EVM, both from kind of like a thought leadership perspective, as well as Anisha saying, like postmortems on every single exploit that takes place, and looking for any kind of changes to the languages or to best practices so that we can make sure the tooling is yeah, on the cutting edge.
When it comes to like the invariance of this, like how the static analyzer finds the invariance, how does it do that? Like, does it just check the like require statements? Does it go any deeper than that?
So we have gathered a bunch of heuristics and insights from again the past hacks that have happened, and we try and infer these invariants out of the contracts that we see. So, for example, if we see that a contract matches, for example, like a bank-like contract or like a vault-like contract, we'll try and replicate and prove those invariants there.
Gotcha, cool. Any other questions?
If there are no other questions, I just want to kind of highlight where we're going, because we do have one more presentation that we're going to do with Atrium. So we focus today on the left-hand side here, the green icons, which is that kind of continuous developer toolkit. These tools are integrating directly into your development workflows. What we also have is a tool that kind of acts as an internal audit agent that is sort of that final scan that you'll execute before you go to an external audit. So the idea behind this tooling is that it surfaces findings leveraging the architecture that powers all of the developer tools that sit on the left-hand side there. So there's a whole bunch of stuff that sits underneath these tools that makes them powerful. You might have seen a lot of kind of AI audit agents popping up recently. Those tools are going to be LLM based. Of course, they're fantastic for kind of pattern matching, but they're only as powerful as the data that they're fed, which means that they can only look to pattern match exactly what they've seen before. And as we know with LLMs, they also hallucinate. So you'll see that they kind of cannot surface as many or as sophisticated findings, and they are also going to produce a lot of noise or a lot of false positives. The idea with the final tool in the stack here with Olympix that we'll dive into in our next session that we'll do in a couple weeks time is that it's leveraging findings from our kind of deterministic rules-based engine, which is then optimized by our fine-tuned AI agents to surface findings and then produce POCs to validate those findings or kind of prove the exploitability of those findings. So what we'll do in our next session is we'll dive into not only how to use Bug Poker, this final tool in the stack, but also all of the other final pieces and final checks that you guys need to make sure that you're doing before you go to an external audit. So it's not just smart contract pieces that you need to cover. There's OPSEC, there's so many pieces that can be mismanaged or can be overlooked that can in turn lead to exploits. And so the focus of our next session will be kind of audit prep overall. It'll touch in part on this Bug Poker tool, but we'll also provide you guys a really robust pre-audit checklist that all of our clients walk through that, again, touches on some tooling pieces, but some other pieces that you guys need to have in place to make sure that you're getting as much as possible as you can from your external audit. But yeah, that's the remaining tooling. And Manuel, you have another question.
Yeah, thank you very much. So, well, through the session, you've been mentioning a number of exploits that have been because the external audit missed a certain vulnerability in the protocol. So I'm imagining, will there be a time, maybe in the future, where I could simply just use Olympix and then have my protocol go live without actually needing an external audit? Because it looks like most of the time, of course, the external audit professionals are really just trying to understand the logic of the code and then seeing how they can try to, create some modifications to make sure that it's secure. But clearly, it's a tedious process, and it's likely that they will always miss out things. So, is there a
Yeah.
possibility that at a certain point, even up to where Olympix stands now, can you say it's possible I can simply use Olympix and then have my project go live? I know it's
So totally fair question, like absolutely valid question. Today, the answer is no. Olympix is part of a layered security approach, which starts with proactive security tooling and then moves to an external audit and then maybe moves to things like on-chain monitoring. So we don't recommend that you only use Olympix. That's because today there are still certain types of vulnerabilities that human beings are better at finding, but there are certain types of vulnerabilities that machines are better at finding. And that's why you should use a layered security approach. When you look at other industries where security is of the utmost importance, it is never a single solution that's in place. And so what we're doing with Olympix and what if you chat to on-chain monitoring companies, if you chat to audit firms, what we're all trying to do kind of in the security space in Web3 is kind of preach this concept of a layered, robust security approach. So today the answer is no. You don't want to use a single solution. You want a layered approach because it's Swiss cheese, right? Each layer that you put in place, some things are going to escape through the holes in the first layer, but they're going to be blocked at the second layer and third and fourth. So the more layers you have in place, the more safe you'll be. That said, especially as an early stage project, I understand that the fact that an audit can be very expensive and you can't necessarily afford the most high-end audit, and you certainly may not be able to afford multiple external audits. And so the idea with Olympix is that it can replace one of those audits, or it can make you more confident in the findings of one of those audits. So what we see with a lot of our early stage teams, for instance, is that if they were planning on getting 2 external audits, by leveraging Olympix, they then are confident in only getting 1 external audit. Or if they were planning on going for, a $200,000 audit because it was their primary or their sole security assurance, when they're leveraging Olympix, they're then confident to go down market and go with a little bit more of a more affordable audit, because again, it's not their only security assurance. So today, the answer is no. Absolutely. We'll see what the future holds. And we are, of course, trying to figure out a way that we can automate as much as possible of what external auditors are doing. But today it's not in the pursuit of replacing that as it is to make the kind of stack more robust altogether.
Beautiful.
Nice.
Yeah.
I think that's everything.
Yeah. Thank you, Sarah. Thank you, Anish. Olympix has an amazing tool set, and I can't wait for our developers to get their uh get their hands on it. Thank you so much.
Absolutely. I'll pop up a slide for a second here right at the end that just has some of our information that you guys can have a look. If you want to check out let me share quickly, you want to check out our website, our LinkedIn, our Twitter, feel free. You can reach out to us. There's a form direct on the website, or of course you can DM us, message us on any of those platforms if you'd like to check out the tool suite. As Raphael mentioned, you guys will have exclusive discounts as part of the Atrium program that we're happy to give you guys. So feel free to reach out and we'll chat about how we can equip you guys with proactive security tools.
Yeah. Website also had amazing resources and a lot of case studies on there too. So feel free to dig in a little deep. Thanks again. Can't wait till the next part. And everyone, this also will be recorded, so feel free to rewatch it again if you missed anything. So thanks again.
Thank you.